Oxidation-reduction reactions. Oxidation-reduction reactions involve the transfer of electrons, and they're sometimes called redox reactions. That always looks like red box without the B to me. Redox reactions are involved in the rusting of iron, bleaching of hair. When a battery makes electricity, it's because of a redox reaction. And many of the redox reactions involve a reaction of something with oxygen. These are examples. When iron rusts, it combines with oxygen and forms iron oxide. When natural gas burns, it combines with oxygen and forms carbon dioxide and water. We need to know what oxidation and reduction mean. Oxidation means when something is oxidized, means that it's losing electrons. And when something is reduced, it's gaining electrons. And so this mnemonic can help you remember that. Oil rig. Oxidation is loss of electrons. Reduction is gain. And this is one of those things where we've got gaining and losing electrons. One's oxidation, one's reduction. Doesn't really make a lot of sense, so we need a little trick to remember it. And I still say oil rig to myself. Okay, and before I spit anything out, because it's just so hard to keep them straight. Oxidation and reduction have to occur together. If one substance loses electrons, which is oxidation, then another substance must gain the electrons. I think of electrons as being tiny babies. You know, you don't just go out and set your baby down on the sidewalk and walk away, right? An atom doesn't just lose its electrons and the electrons are just out playing by themselves. They're too tiny. They have to be with someone. So if you're not going to have the baby with you, then you have to hand it off to someone else. You have given it to someone and someone else has received it. You can't just have them coming and going. So if one substance loses, the other one gains. If a substance is going to gain electrons, those electrons have to come from somewhere. There's no electron bank where you can just go and withdraw electrons. There's no electron shelter where you can dump off your unwanted electrons. All we're going to need to know right now is how to identify redox reactions. So here are our guidelines. If we see a substance reacting with elemental oxygen, if O2 by itself is one of the reactants, that's a redox reaction. If we have a metal reacting with a nonmetal, it's a redox reaction. The metals want to form cations, they tend to lose electrons. The nonmetals want to form anions, they tend to gain electrons. So when you get those together, there is often an exchange of electrons. And just more generally, anytime you have one substance transferring electrons to another substance. So we should be able to do things like this, predict which of these are redox reactions. And so we're going to think back to those things we talked about on the previous slide. Lithium plus chlorine, forming lithium chloride. Is that a redox reaction? Yes, it is. Here's a metal reacting with a nonmetal. Because what's happening here? The lithium is losing electrons to become an ion in this ionic compound. The chlorine is gaining the electrons to form an ion. So that one is a redox reaction. How about this one? What's going on with the aluminum here? Here's aluminum, the element, and it's becoming an ion. Are electrons moving involved in that? Yes, they are. And here we've got tin as an ion and tin as an element. That's a redox reaction. How about C? Is that a redox? What kind of a reaction is that? See this S here? That's a precipitation reaction. Here we've got lead ions And over here we have lead ions. They're just hooked up with somebody else. Here we've got lithium ions, and here we've got lithium ions. There's no electrons being transferred. Partners were swapped, but no electrons changed hands. So that's not a redox reaction. How about the last one? Yes. Something reacting with oxygen. That's a redox reaction. Any questions?